Okay, hello. Sorry for the delay. Welcome to week 3. I know this class seems a little bit empty today. I got a bunch of messages about people going to exams, so I'm assuming that's why. It's midterm season. I have a midterm tomorrow, so I'm sure you probably have some coming up too. Um, but yeah, last week's homework again. It is a pretty difficult one for most people. So like if you didn't get all the constraints, like don't worry about it. I might like make a solution video later so you can kind of look through it. If you want to submit it again later and you want like help with it, that's okay. I'm not gonna like take points off for it being late because I know it's a hard assignment. So if you want to take your time with it and do it right, uh, feel free to turn it in later when it's like fully constrained. Uh, yeah, don't worry too much. Again, that was the hardest assignment in my opinion. I think the final is a lot more fun and a lot easier. Um, but we just wanted to expose you to that kind of stuff. Uh, just because if you can do that well, then a lot of the sketches that you might create in the future will be like top notch. So yeah. We also have a wonderful TA in this class now, so I will let him introduce himself.
Guys, I'm Juan. I'm a junior in mechanical engineering technology, and I'm currently Andrew's TA this semester. So I'll be here every other week. I'll be walking around, seeing if you guys need any help. Definitely raise your hand like during like while he's teaching and things like that, and I'll come around and help you as much as I can. I know there's gonna be a lot of troubleshooting issues and things like that, but there should be no worries. You guys are gonna be all right. We'll be passing this class together. So that's a little bit from me. Like I said again, during while Andrew's teaching, I'll be floating around. If you guys need help, raise your hand. It'll come out.
Yeah, and then also I've seen some people asking questions on the Discord. That's very nice. So if you have any questions, just like hit us up. I'll try to respond as quickly as possible. Again, it's a resource for everyone. So a lot of people may have the same question, but they might be too shy to ask. So if you're the first one to ask, you could be helping someone else out, uh, including yourself, right? So please use it as a resource. We're here for you. Yeah, without further ado, let's get started on today. Okay, so for assignment 7, we're going to be doing something a little bit different from what we've been doing before. A lot of the times when you're designing stuff, you might want to reference something that already exists in real life, right? So, you might have a photo of like some piece that you want to design around. And one way to easily reverse engineer something is just by taking a picture of it and then like kind of using the photo as a reference, right? So today we're going to be reverse engineering the engineering fountain at Purdue, but this kind of can do very many things, right? Um, so yeah, we'll just get right into it. Um, in the resources here, I have this nice like side shot of the engineering fountain here. Feel free to download that, and then we're just going to be using that in Fusion today. Uh, if you're wondering where it is, it's under the resources tab in the Discord. If you can't find it. If you can't find it, raise your hand. We can help you find it. Okay. So once you have that downloaded, you're just gonna go into your data panel and then find a spot where you want to put the file. So I'm just gonna be putting it in this Spring folder. Oh wow, I'm lagging. Great. And then you select the file, probably in your downloads folder. It'll confirm the file that you selected. You just press upload, just like the geometric constraints assignment. Oh wait, no, that's not what we're supposed to do. Sorry. Um, I'm just gonna leave that there. Um, so we also have this new design here. And then to insert the photo, you're just gonna select canvas here. So you can see when you hover over it, it'll give you a preview. You click on it, and then you can select the file. And then it asks you to select a plane again. So 2D images are on a 2D plane, so you have to tell it where you want to go or where you want it to go. In this case, I'm just going to be choosing this front plane right here, but this like right plane also works as well. If you click on it, you can see it kind of renders the engineering fountain here. Over here, there's a bunch of settings that you can change, like the opacity, so like how see-through it is. So if you change this, it gets lighter or darker. I'm just going to leave it at 50%. But then you can also change the scale, right? So for example, if your photo had like something with a specific dimension in it, you could set the scale so it could be proportional to the other stuff that you want to create around it. So I'm just going to leave it at the current scale because this is just kind of a representation. So I'm just going to press OK. And now we have this lovely canvas of the engineering fountain. So we're going to do something kind of similar to the gear assignment that we did last week, where we're going to model one part of the engineering fountain, and then we're going to make it copied around in a circle. So to do that, we're just going to make a sketch, just like we've been doing. So top left, I'm going to select the plane that the canvas is on, and then I'm going to start sketching. So you don't have to be like super exact. I'm just drawing these lines here. I'm actually just going to extend this all the way out here. Add another line there. And why not add some dimensional constraints here? Okay, sweet. So I'm going to offset this from the origin right here. 0.7 seems good in this case. This length, I'll set this maybe like 3.9, and this to like okay. So again, this isn't like super exact. We're just kind of eyeballing the fountain here. Gonna add a little bit more. Okay, sweet. Oh, there's one more. Okay, so we have these kind of 90-degree angles, and then we're gonna add like this radius here. Fun fact, if you didn't know, I believe the engineering fountain is like based on the e to the x function. So this isn't actually a circle. It's kind of like a progressive curve. So you can't use a circle. So we're going to use a fit point spline like we did for the wire in the hairdryer assignment. So I'm just going to click my way down here. Personally, I like to put points on the fit point spline, like at the end of each of these little segments, and then I continue down, and then I'll trim that away later. So I have that there. If I hide the canvas, you can kind of see where this curve is coming from. I'm going to add 2 more vertical lines here, and then I'm going to trim the excess. But if you want to make 2 splines, that's okay too. So I'm going to hide the canvas again so you can see I have these right here. Why don't I add some dimensional constraints? And then I'll trim the excess. So the trim tool, I'm going to cut that away and this away. Don't worry about these green lines. Those are kind of representing the curve on the fit point spline, but they're not actually like going to be part of your extrusion, which we'll do in a minute. So this looks good. I know this fit point spline isn't fully constrained, but I think that's totally fine for this assignment. So I'm happy with this. I'm just going to finish the sketch and then I'm going to extrude it. I'm going to be extruding it improperly on purpose so we can go and fix it later. So I'm just going to do it just so you can kind of see what might happen if you do it improperly. So I'm just going to treat it as like a normal one-sided extrusion for now, but I'll come back and fix it later. Okay. Sweet. Does everyone have this? What's up? Yes. So just like you can extrude it as how I've done it, so we can go back and fix it later. Uh, So now that most of you have gotten this, oh wait, did you need help? Okay, so now that we have like this quarter of the engineering fountain, we're gonna pattern it. So just like in like the gear assignment, you can pattern bodies along with like lines and sketches. So I'm gonna go under create and then pattern, and then circular pattern, and then it'll allow me to select different bodies, uh, or like components or whatever. In this case, I'm just selecting bodies because we have two of them here. So if we click these two, they're highlighted blue, and then we have to specify an axis, just like specifying the center for the sketches. So I'm going to click on this right here, and then I'm going to change it to 4, and then I'm going to press OK. You can see this doesn't look quite right, and it's because of the way we extruded it initially, right? So if you extrude it like single-sided and then you pattern it like this, it's going to be a little bit wonky. So to fix that, we're going to edit the extrude in the timeline. And then instead of one side, we're going to make it symmetric. And then when you do that, you have to kind of divide the initial number by 2 to get the same width. And then when we press OK, you can see that now it looks a lot better, right? So again, I just kind of did that to show you like the way you extrude things can have an effect on like things afterwards, like your patterns and stuff. So just keep that in mind. Does that make sense? Yeah. So when you went to fix it, you right-click the extrude in the timeline, and then you change the direction from one side to symmetric. And then you have to change the distance to half of what you had before, because it extrudes it both ways. Yeah. Okay. So now that we have this like simple version of the fountain, you can see that like in the real one, there's like this cutout here, so some extra detail. We're gonna go in and make that. You can kind of draw whatever like extra detail you want. I've had people do like smiley faces and stuff, but I'm gonna just try to copy it to be relatively accurate. So I'm gonna create a sketch, and I'm gonna create it on this plane right here. You can make it on like the original sketch plane, but you can also do it on the face. It doesn't matter that much as long as you know how to extrude it later. So I'm just gonna select this outer face, and then I'm gonna start drawing these details right here. One cool thing I can do is I can project the lines, the existing lines that we used or that we created before. So I can project like these 3 and these 3, and then we can use that kind of as a foundation to build off of our model. So with those, I'm gonna make another spline over here, maybe start like here. Again, these are kind of arbitrary, so I'm gonna leave them unconstrained. I have one spline there. And one there. Okay. So if you were following what I was doing, you should get kind of a little thing that looks kind of like this. Again, you can see that utilizing these projected lines, we have these closed shapes right here. So that's nice. And we should be able to extrude with these right here. Did I lose anyone? Yeah, so when I projected the line, I basically used the edge that we already created from the body, and I brought that edge into the sketch, right? So like if you want to create, like we're cutting straight out of this piece right here. So to like precisely have the edge, instead of just drawing a line on it, you can project like the edge, if that makes sense. So if like the edge were to change for whatever reason, like if it got bigger or smaller, the projection will follow into the sketch that you created after. Um, does that make sense? Does that make sense? So now that I've created the sketch, I'm going to go in and cut these details out into the fountain. So I'm just going to extrude it, and I'm going to select these profiles, and then I'm just going to make it go into the body like this. So for me, I don't know, I'll do like 0.2 or something, and then I'm going to press OK. You can see we've created this profile here. If you happen to create the sketch like on that center plane there, what you might have to do, let me see if I can change this. Okay, cool. So if you drew it on the on like this center plane here, it's gonna like make it a little bit more difficult to select the profile because it might just assume that you're selecting this face. So to fix that, you sometimes have to like hide bodies so you can get access to your sketch, and then you can select the profiles. Uh, if you did it in the center as well, you're also gonna have to change the start of your extrude, right? Because if you drew it in the center, the start is in the middle, but we want to cut from the outside. So to do that, you would change the start from profile plane to object, and then you would select the face that you want to start cutting from. So right there, and then you specify like the cut direction, and then you press OK, and then you should have the same result. So again, there's no like wrong or right way to do this. Like those are two perfectly like okay methods of doing this extrude. It's just kind of like a preference thing. Does that make sense to everyone? Okay. So now that we have this, the other thing we want to do is we want to mirror that like same feature onto this side. Again, there's more than one way of doing it. You could just do the extrude just like you did for this side, but instead of using this face as the start, you can select it as here. So you can do like the whole object thing, but you can also do it as a mirror, right? Again, there's no wrong or right way to do it. It's just preference. Personally, I kind of like mirroring stuff, just because if I was to change like the depth of one side, then the mirror will change it for both sides, right? But if you wanted them to be different, then that's when you might want to choose an extrude. So I'm gonna go create mirror, and then instead of bodies under object type, I'm gonna change it to features, right? And then so for features, I'm gonna select this feature right here, and then I'm gonna select the plane being that center plane that we sketched off from the beginning. And then if we're doing it right, it should, oh, we didn't do it right. There we go. last couple steps for this one. Again, I'm purposely drawing these things out of order, just so you can see how things work on the timeline. Um, I really hope that the features that you created were on the uh, like the initial body we created and not the one of the three patterned ones, because now since we kind of created it out of order, we can move and change the order to kind of make everything identical, right? So again, if you made all of these on the initial body, it means that the circular pattern isn't dependent on anything, right? And if it's not dependent on anything, you can move it forward in the timeline. So that means if we drag this, we can move it after the features that we created, like those cuts and the mirrors. And when I let go, uh, all the features will be copied to the other three pieces. So that's what we're going for here. If it's not dragging, then it probably means that you might have either like a sketch or an extrude that's dependent on one of the bodies you've created. So for the last thing on this, pretty simple. It's just making a base for it. So I'm gonna kind of speed run this. I'm gonna create a sketch on the bottom face, and then I'm gonna draw 2 circles off the origin. Do like 1, 2. I'm gonna add some dimensions real quick, like 12. Oh. And then just gonna extrude it, and then we're gonna call it a day. Okay, sweet. Engineering fountain. Everyone good? Hopefully. You can make this like 3 miles long if you really want to. That's fine. Okay, so now that you kind of have sketches down, hopefully, you're kind of proficient in making sketches and making models, and that's great and all, right? We need to create models to make stuff, but a lot of the times you want to combine more than one model, right? When you design a system, you typically aren't just designing one part, so to put them together, we make things called assemblies, right? Oh, I'm gonna click through these. Okay, yeah. Just like extrude it down, and then like I think there's like a lonely rectangle that you also have to select. Yeah. Yeah. Anyways, typically a lot of the things we design have more than one part, so we need to make assemblies to put them all together, right? So assemblies are great because you can kind of visually see how things are going to go together before you actually make things in real life. And if you're paying like close attention, you might be able to catch some like errors beforehand, right? So a lot of the times when we CAD stuff, we kind of put things in a virtual space, but because it's virtual, it's not like confined to like any rules, right? We can have like parts phase through each other, uh, which is usually not ideal because things can't phase through each other in real life. So if you're paying attention while you're making assemblies, you can maybe catch these things before you actually do it. Sometimes you don't, and then you get sad. But yeah. Anyways, to do this, I have this zip file over here in the Discord. So if you go under resources, you can download it. It's not a zip bomb, I swear. I'm not gonna brick your computer. Oh yeah, also if you haven't filled out attendance for week 2, I would recommend you fill it out because we hit 84% last week. And if you like weren't here or you were here and you forgot, I would fill it out because if you want free food on the last day, we need to hit 90. So I'm giving you the opportunity now to fill it out. So yeah, random side reminder. Anyways, going back to Fusion, once you download the files, you're gonna have to extract it. So where is it? So unzip that zip file or downloads. I personally like making a new folder just because we're importing a bunch of stuff. So I'm making a folder here, and then I'm gonna select upload. I'm gonna find that extracted folder and then just copy everything on there. It might take a little bit, so just give it a second. Is anyone having trouble finding the files? Hopefully not. Okay, cool. All right. So over here, we kind of have a couple of these pieces here that we can use to create our assembly. But to start, we need to make a blank canvas. So we're going to do a new design. When you make assemblies, you have to make sure you save the assembly file before you put anything in, because it's not going to let you unless you do. So I'm just going to Control S. I'm going to call it something Lego car. And now that it's saved, I can start inserting components, right? So for this, I'm going to leave my data panel open because we're going to be referencing a lot of these. So I'm going to start with what I find to be like the foundation or like the frame of the car. Typically when I make assemblies, like the first part I choose is always like a base piece, right? Like if I'm going to make an assembly of a car, like I'm not going to make the wheel like the foundation of the car, right? I want the frame of it to be the foundation. Obviously, like if you want your frame or want your base to be a wheel, like go for it. But my personal preference is just kind of picking like what I consider like the most important part or the foundation first. So in this case, uh, when I look at this Lego car, uh, I kind of think that this like 2x6 like plate is the foundation. So I'm gonna find it and then I'm gonna insert it into the assembly. You should be able to drag and drop, or you can right click and do insert into current design. They both do the same thing. It'll load the part in. It will kind of place it near the origin in kind of like the orientation it was designed in. Personally, I think this is fine, so I'm just gonna leave it as it is, and then I'm gonna press OK. Um, okay, so one thing to note is that when you insert your first part into your assembly, it's gonna be grounded, right? So your first part will always be grounded, right? And it's kind of like making an origin for your assembly. Um, and it just kind of places it and fixes it in place. So it's kind of like the 3D version of the fixed constraint. But it's okay for the first part because you want everything else to move in relation to that foundation, right? So if you look in the top left, you can see there's this little anchor icon on top of this component. And that's just to signify that it's anchored and it's not going to move, right? So that's good. We like that. If it doesn't anchor for whatever point, for whatever reason, you can like ground it right here. it gives me the option to unground it because it's already grounded for me. But if it is ungrounded, then you should ground it. It just makes it so this first piece doesn't move. So yeah, all the parts that you'll join it to, um, it should do it automatically. So if you look at the component right here, there's this like tiny anchor icon above like this. Yeah. So it should do it automatically, which is good. It used to not do that and it was really annoying. But yeah. Anyways, we have this nice foundation, but an assembly isn't just one part. So we're gonna start inserting more stuff. For me, I kind of like going with the buggy wheels next. So I'm gonna start inserting them if I don't lag too much. These. Okay. So I'm inserting this part. You can kind of see that it's phasing through this original part just because it kind of spawns it like right on top of the other one. So you can use these arrows to kind of move it around. You can see like if I put it here, it's really close to where I want it to be. But personally, I like to move it a little bit farther away, just to confirm that it goes into the right place when I join it. So I'm gonna just kind of move it farther away, and I'm gonna press OK. See, there's this nice gap right here. So yeah, to connect two pieces together, we're gonna use something called a joint. So fusion assemblies like to use joints. You basically select like two different things and then have it like fly into place, right? So there's a couple of different ways you can use joints. And I'll just show you a couple ways that I prefer to do it. When I'm joining like two like pieces that have a lot of edges on them, I like to select like faces, right? Personally, like my preference is like using faces, and the main reason is if I edit like one of the edges, like if I add a fillet or a chamfer, then it might break the joint, right? Because if I go back into the assembly and that edge isn't there anymore, then Fusion's gonna be sad, and it's gonna like get really mad at you. So I like to use faces. Uh, so typically I'll use like the between two faces joint, and then I'll select different parts that correspond with each other. So there's two planes here. I'm gonna select like this plane and like, I don't know, this one. And then for the snap, I'm gonna select like this right there. And then for the second component, I want to make sure like the plane numbers correspond with each other, right? So for plane 1, I selected like this face over here, and then plane 2, I selected this one over there, and then the snap was like that bottom face. So I'm gonna do the same thing and match it on this piece. So I'm gonna select one plane here, one plane there, and then the snap plane is there. And that does not look right. What in the world? Okay. There we go. Okay. I don't know. Okay. This is personally the fusion like joint and assembling things is one of like my biggest frustrations with this program because it's not really like logical. It'll just kind of like go wherever it wants to go. But I'll do it again like a couple times because it takes some getting used to, especially if you've done assemblies in other programs. Yeah. This joint feature has actually changed since the last time I taught this class, so we're kind of learning as we go too. So this is lovely. Okay, so I'm inserting like another axle piece here. Yeah. Okay, I'll do it again. It seems like snapping to two faces isn't working really well. So I'm gonna snap to like a vertex or like an edge. So I'm gonna make a joint between two faces again. I'm gonna select this plane and this plane for 1 and 2. And then I guess for the snap, I'm just gonna select like this bottom like vertice or corner right here. For the component 2, this face should be joining up to this one, and then this face should be joining up to there. So plane 1 should be here, plane 2 should be there, and then the snap should be on this corner because we want that bottom corner to be flush with this one, and then it'll fly in place. Yay. What's up? So yeah, I know these joints are like kind of frustrating, but like don't worry, that's just kind of how it is. Um, and you'll kind of see sometimes like the piece will kind of fly away from other parts when you're in the middle of a joint. But when you press OK and confirm it, everything will kind of go back to how it was before. So yeah, I've done 2 now. I'll start doing some more. So don't worry, you can just kind of follow along. I'm just gonna be doing it a bunch of times. So I'm just gonna leave this here for now, and then I'm gonna go over something called subassemblies. So the cool thing about like a lot of CAD programs is you can nest assemblies inside of each other, right? So for example, like this car has 4 wheels and 4 tires, right? And that doesn't really change. So what we can do is we can make a separate assembly that's just a wheel and a tire, and then we can import that as one thing. So I'm going to create a new design. I'm going to save it. And then I'm going to insert both the tire and the wheel. Personally, I like putting the wheel in first because I think it's kind of like the important one to start with. We have this wheel, and then I'm going to insert the tire. Again, it looks like it's in the right spot, but because it's not joined, I like to move it away and then join it. So I'm going to create a joint. For round things, I personally like to just do simple joints. So it's like the first option. In this case, like you kind of have to select edges. So I'm gonna select this outer edge on the wheel and then this inner edge on the tire. And if you double click it, they should fly into each other. I'll do it again. So it's joint. For like round things, I like simple joints. So I just select one edge right here, and then I double click this other edge, and then it flies into place. And yeah. So we have this wheel subassembly. You want to make sure to save it. And now what we can do is we can insert our subassembly into our main assembly. Right, so we have this wheel and it's both pieces now. So that just makes the number of constraints we have to do later is less. For the wheel, the assembly is like kind of weird, and it's mostly because like the kind of Lego axle that it's modeled after has a bunch of different like arcs and lines associated with it. So if you're not careful, you might be selecting like the wrong place to join to. Um, so I'll show you right now. When we create joints, this edge is pretty easy. I want like this part of the wheel to be flush right with this right here. I'm gonna leave it as simple because I'm working with circular stuff. So I'm gonna choose this edge here. But then for the edge on this wheel, if you're gonna select one of the center pieces, you have to be very careful, right? Because if I was to like if I was to move my mouse, you can kind of see there's like a really mini like origin looking thing that hovers over my mouse. But it'll like try to snap to like one of the closest like edges, and sometimes it'll snap to the wrong thing, right? So if I move my mouse like closer, you'll see that it's like snapping to this corner. And if you're not paying attention, if you snap to it, you can see it's like not in the right place, right? Uh, and then when we apply like a different motion type to it, because like wheels spin, right? If I change it to revolute, you can see like this is like definitely wrong, right? So I don't like that. I'm gonna fix this. So I'm gonna cancel that original one and I'm gonna fix it. If you see like if I'm being more careful, if I put my mouse on this arc right here, you can see that the mini origin is snapping to the center of like the circle, right? And that's what we want. Again, if you're not like careful, like it might snap to like the middle of this arc and then you'll be spinning weirdly again. So again, just pay attention, make sure that little origin is where you want it to be, because when it is, and you apply the right motion, then it spins true. So that's nice. Obviously, you can see like this axle piece is spinning and not the wheel, but don't worry about it because once you press OK, like this axle piece is rigid, but like this wheel is not, right? So I can like drag and spin this wheel now, which is good. It's okay. I'm just gonna be doing it like over and over again. So if you're like missing anything, then I'll just do it again because I know these are kind of funny. The wheels is spinning because the joints that these axles are associated with are rigid, right? Because like this piece right here, like the base plate is fixed, and then these axles are like rigidly like joined to it, so it won't move. Okay, let's do it a couple more times. Oops. One of my recommendations, if you haven't noticed already, is that like you kind of want to orient the part to be close to the orientation that it's going to be like joined in. Kind of like when you're doing like the vertical and horizontal constraints on a sketch, like Fusion will try to like join it to be the easiest for it. And if like your wheel is backwards, then it'll join it backwards. So you kind of have to orient it and kind of help the program know what you want. So you see like I rotated this wheel 180 degrees. So this outside is facing the direction I want. And then I'm going to join it. So there, I'm going to make sure it's like centered on the center of the hub and it's spinning. So again, if you want to make sure your stuff is like spinning and stuff, you go from the position tab to the motion tab, and then you can change it to revolute, right? So that's how you make things spin. When you want things to not move, you leave it at rigid. I'd say like those are the two most common ones that you're going to be using. But there's more like advanced things, like if you want things to like slide along an axis or something, you can do that. But for this case, revolute is fine. I'm going to confirm that. I'll do a couple more. Okay, I'll do like a couple more. Let's do this roof. I'm gonna make a joint. Click these two here, and this edge or vertex, and then these two, and then the corresponding one. I do not want it to spin like that, so I'm gonna change the motion type to rigid, and then I'm gonna press OK. Oh, I'm just like putting in a bunch of parts, but like they're essentially like the same thing, right? So, let's see. Let's do this front little piece here. I feel you. Yeah, it's like kind of weird. You'll eventually like get a feel for it, but it takes some getting used to. Oh gosh. Dude, I'll just like make more Lego cars. Dude, this is a new speedrunning category. Oh, yes. Looks great. Just make sure you apply appearances. I will not. I will not. Yeah, I don't know. Yeah, it's that piece is kind of weird. You could potentially like make a mid plane on this and a mid plane on that and constrain that. Yeah, I haven't tried it though, but that might work. Personally, I don't I don't really mess with assemblies in Fusion very often, so yeah, I cannot say that. What? Oh, that like horizontal piece. Oh, I did simple for this, and then I just kind of like dragged it with the arrows. I mean, the order at which you place the parts doesn't really matter. What? Okay, yeah. Some people were asking about the homework. So I'll go over the homework real quick. We have like 10 minutes. Uh, so okay, I'll just talk about it right now. So for your homework, I'm asking you to design like your own like Lego set. It needs to be a minimum of 25 Lego bricks. If you want to use 25 of the same Lego brick, I'm not going to stop you. I'm going to encourage you to not do that. I just don't want to get like a stack of bricks and then call it a day. Um, technically, you can. I encourage you not to. Um, one of the things I'm going to show you now is that you don't have to use the pieces that I've given to you today, right? There's a lot of online repositories with a bunch of free files that you can download and you can use them. Um, I don't know if the scale's right on all of them, but here, I'll just show you. Um, there's going to be like a couple resources I can send out later, um, but I'm just going to show you one example. Uh, so like one of my favorite repositories is called GrabCAD. Um, GrabCAD like community or something. Yeah. So GrabCAD community is like an online repository of a bunch of stuff. If you 3D print stuff, like you might be familiar with stuff with websites like Thingiverse and stuff like that. GrabCAD is basically like that, but for everything that you can think of. Uh, you can see here like people make like computer chips and stuff like this on here. And it's a really great place to go when you're modeling things. So like for example, a lot of the things that I make use like skateboard bearings because you know they're cheap, they're really easy to find. So if you want something that rolls, skateboard bearings are a pretty good go-to. Um, so if you didn't know, like the official name for the skateboard bearing, like the size is called 608. So if you type in like 608 bearing, you can see there's like a really long list of different models that people have already made, right? So if you're designing something that you need a certain part for, something like GrabCAD or an online repository can save you a lot of time, right? Because if you're designing something like you really don't want to be like CADing a standardized bearing because like they exist and they're standardized, right? So you can just pull like designs and files off the internet and use it. It makes it really convenient. Um, if you want to go for like hardware and stuff, like you know, I'm using a 608 bearing as an example. Um, McMaster Car is a really great place to go. You can actually like buy a lot of these things, or all of these things. But you can see like they have a really wide range of different hardware options. So if you're designing something with like bolts and stuff, you can download like let's just find some random bolt. You can download like the CAD model, right? So oops, typically I would use something like a step file. Um, no threads is nice because it just saves your computer some processing power. But you can see part of the point of this homework assignment is for you to explore these repositories because they're a really great resource, right? Obviously, like you should know how to use assemblies now since we made a Lego car in class. Um, but yeah, just know that these resources are out there and they're not just for finding Lego bricks, right? But again, you can find stuff on here. Probably won't find Legos on McMaster, but yeah, you can see there's like full sets. Please don't send me like one of these. Like that's just like cheating. So uh, like you can download bricks and stuff, but like if you send me this, I'm gonna be like, wow, you spent like 10 hours like assembling this. Like I really hope you didn't do that. So yeah, I think there's a couple other websites that I have on a list somewhere. I'll send it later today. Um, but yeah, that's your homework assignment. Again, if you want, like you can stack 25 bricks, but please don't. No, you don't need to like make your own bricks from scratch. Like if you want to, like you could, but like um, I wouldn't recommend it. Um, yeah, you can have fun with it. I think in a past session, someone put like these nuts in like Lego bricks, and that was interesting. Oh yeah, okay. But yeah, if you're done and you want to leave, go for it. Thank you so much. Uh, make sure to fill out your attendance forms or bug your friends to fill them out, uh, so you can get free food on the last day. But yeah, that'll be it. I'll walk around and help everyone else who might need help with joints. Yeah.